He said multiply. You said divide. Get your foot off the desk. You're not at home. All right. So,
First of all, that's the force, and that's the math.
these y'all. Why am I going to yell at you? Look what you did. Keep your hat off your head. All right. So what's the formula that we're going to use? Okay. F equals MA, right? That's the formula that we've learned for this unit. F equals MA. No, it's no P. All right. Force equals mass times acceleration. So the question is asking you, all right, F equals MA. It's asking you to find what? What is the force? 35.6. Hold on. Does it say what is the force in the question? No. It says what is the acceleration. So are we solving for the force? No. We're solving for the what? We're solving for acceleration. So we got to have a force in the question. So what is the force?
35.6.
All right, so 35.6 has to go where F is. So what is the mass?
2.
Okay?
Divide by 2.
So if we're solving for A, if this is multiply, what's the opposite of multiply?
Divide.
So we're dividing by 2. So what's 35.6 divided by 2?
17.8.
So A equals 17.8. And where did I tell you yesterday you could find the unit if you didn't know it?
M/S/S. Right?
Yes, and where did I say you could find it?
On your yellow paper.
On your yellow paper. Now, those of you who are eating those chips, you got about another 3 minutes to get them eaten. It's like Chip Central in here today. I don't know why we're selling chips and eating them like we're scavengers today. I'll eat them. Eat them quick. Hurry up. Before some administrator shows up and wants to know why we're Chip Central.
Well, it doesn't happen when you get 31.
Huh? Well, I get it. I said, you have something small, like a piece of candy that you shove in your mouth, not 12 people eating bags of chips all at once. They had grab and go between first and second, so you could have
Go.
I can't fix it, it's stale.
Them donuts be stale.
I can't fix that. Right now,
Don't be stale.
Newton's 3 laws. You've got to know which one is which. Newton's first law. What does it say? That's inertia.
Motion that thing that's at motion stays at motion.
Very good, Abigail. Did everybody hear what she said? Thank you. Put them up. So, if an object is in motion, it stays in motion. The key word for that is inertia. Now, I'm about at least halfway, maybe a little more than halfway, done grading yesterday's lab papers. A lot of you told me that yesterday's lab was Newton's third law. What's the title of yesterday's lab paper?
I forgot. First law.
We got out. Hold it up here. Hang out in front, you can see it. What's it say in the top? It says inertia lab, right? What law was inertia? The first law. Okay? So, the inertia lab is Newton's first law lab. So, it should not say Newton's third law down here at the bottom of the paper. Which is why I keep drawing arrows down here to the question 1 at the bottom where everybody get right Newton's third law.
I got nervous.
Okay? You got nervous. All right. So, what does Newton's third law say? It says y'all can't tell.
For every action, there is a reaction.
All right. For every action, there's an equal and opposite reaction.
Yeah, sure.
Okay. So, if I push down on the floor does what? Pushes up. You guys are sitting in a chair. You push down, the chair pushes up. If I was just saying, if I jumped off a boat, I push down on the boat pushes up. The boat's going backwards, I'm going forward. Hopefully I'm going to land on the dock, but honestly I could wind up where? In the water. Hopefully not in the shark's mouth. I'm not going to jump across the shark and touch the water. I'm not stupid. I didn't yet. So what's the second one?
Formula.
That's the formula one, so what's the second one? F equals ma. So if I throw something with more force, it will accelerate farther or faster. Okay? If something has a bigger mass, it's going to accelerate quicker or slower? Slower. Okay, you guys found out yesterday in your lab, something with a bigger mass went, it didn't go as far. It went a shorter distance. Okay? All right, the last one. What are you solving for at this question? And don't all yell force this time. All right, it says mass. So this time we're looking for M. All right, so what's by force?
Wait.
Okay, because it's a Newton, right? Force always has to be a Newton. Times, what's my acceleration? Okay, so how do I solve for my mass? Divide by 5. So mass is going to be equal to what? What's 150 divided by 5? Y'all was the calculator. 30, and what unit do I put on a mass? Kilograms. Kg. Always for mass, yes. Mass. I mean, sometimes if you write grams, I won't mark it wrong because it is a mass unit, so I won't mark it, but it should be kgs. All right, questions about anything in the open? No. All right, find your homework and your 1 through 6 that we were working on yesterday. We're down to it. Let me see if I got any extras.
Boy, shut up. Oh, he was at home playing with his fingers.
All right, so who was absent? I need to give one to. One, 2, 3. Did I give everybody one who's absent? All right, so if we look at your homework,
You ain't taking it?
not today. Most of you had 1 through 4 or 5 done before you left the room. And then I'll hand back quizzes after we do this. They were pretty good. There were a couple that weren't as good, but most of them were really good.
Yeah, and I know one of those couple work.
It was still, I think, okay. Question 1, 25 kilograms. Anybody need to do number 1? Oh my God! What is wrong with you? I can't fix stupid.
Hey, tell me about it, be saying.
Where do you think she got it? No, sit down. Stop putting crumbs in your eyeball.
I guess it's on purpose.
Yes, you did.
You can't fix stupid. Stupid.
Then nobody can fix you. Sit still. Sit still. Keep your hands out of your eyes. And try not to put crumbs. Number 2. 7.5 newtons.
Can we answer this one?
What was number 1?
25 kilograms. I just said a minute ago I was not checking it.
You said number 2 is what?
I didn't make you do it for nothing.
It's not for nothing.
Hopefully it means you will pass the test
That's
right.
why he got his 0.5.
Hopefully nobody in here has a 45 GPA. That's like doggone near all F's and a B. All right.
50
Number 3 should be 50.
meters per second.
There you go. 50 meters per second per second. Number 4.
15.30, right?
1470. 1,470 newtons.
Get it.
Hi, because I told somebody the right answer and they said I was wrong. So
So you change your answer.
Okay.
because I was asleep and I told them, I said, I may have been asleep, but I still right. And they was all wrong.
Number 4, you have a hanging birdhouse, right?
Now you just want to 1 feet, something.
So, what's the mass of the birdhouse?
150.
And what did we say we'd put in for acceleration if anything is hanging?
0.8. You get that good old.
That's how you get 1,470 newtons. Cynthia. All right, number 5. Now, in number 5, it says use the people. In number 5, it says use the same birdhouse, right? So what's the mass of the same birdhouse? It's still 150, but this time it says you accelerate at what rate? So you're going to put 2 there. So what's your force going to be? 150 times 2 is 300 newtons. That's number 5. And the last one is number 6, and you get 49 newtons. Any of those questions? Anybody have a question? All right, so it says, Devin, it says you have a 5-kilogram block falling freely due to gravity. So if you have a 5-kilogram block, the mass is 5, and if you're falling freely, what's pulling on it? Gravity, right? So 9.8 is your acceleration. So 5 times 9.8. And that's how you get what I call out 49. And then newtons. Yes. All right. I want to do 7 and 8. I don't want to do any of the rest of them, but I want to do 7 and 8 because you're going to see something like 7 and 8 on the test. Okay?
Yeah.
So try 7. Just try 7. I strongly recommend you label what you know. For example,
Would you have the times together?
you only have one time. You don't have multiple times. Like, write down what your mass is, what your velocity is, what your time is, what your A is. Figure out what you know to do number 7. I'll hand back some papers. These are questions a lot of people get wrong.
Wait, so don't we do velocity equals,
You still on that?
Y'all, stop talking. Try number 7.
What's the T?
What are you putting?
I wouldn't even get this.
I had it on
69.
because it's all in the air.
How I get a 54? And then you walk 200.
Why?
it's static.
It's just heavy. It's heavy, but I'm pushing it.
I can see it, and I'm going down.
The other way.
You're not getting one.
I can
That feels smooth. All right. These y'all, unless you want me to have that hat, take it off your head. All right, so if we look at the quiz paper, the biggest mistakes that were made were in the top 1, 2, and 3. They were not made in the types of friction. What? Huh? There are 3 people who weren't here, but I don't think they're going to make it up today. Oh, well, then well, Half y'all had to pay that anyways. Yeah.
You think so?
After school, no. I'll be here during lunch, but I will not be here after school. But I'll be here tomorrow after school.
Better make it up in the lab.
I'll be glad to do the lab. I mean, honestly, it's a personal issue today. My daughter's birthday today. She's asked that I'm not after school today.
She's a
Okay.
She's been
I'm a hitter.
crazy.
I'll be looking at you.
So I promised I would not be late picking her up from school and practice today. I'm gonna stick to that. Because normally I just leave them sitting there and I stay here. So if we move on, at the top. Yeah, actually. Now, if we look at the quiz, what do you say, Tim, Jonathan, and Carlos in the hallway, so that I don't upset the rest of y'all, because there are a couple we do need to talk about at the
Don't
top.
forget about my.
Get out. There we go. Get out. Right now. Close door behind you. Hurry
Get
up.
the step and partner.
Oh, he said,
Stop
step
the
Hurry up.
Get out, Los.
Get out.
Get the board.
This wall, we saw our wall, gravity pushing them down.
Gravity does push it down, God's on the edge.
I know the end.
If you look at,
Close that door. He
y'all stop.
I'm trying to eavesdrop.
If we can't get to the lab today, we'll just strike number 4 off.
Oh, no, we're gonna get to the lab.
Then stop. If we look at the top, a couple of us missed number 1, but very few did, okay? The question that asks you are Haley, so I know what the questions say. Alright, which type of force will cause an object to move? A couple of you did say balance, but that has to be what kind of force? Unbalanced. In order for an object to move, it has to be unbalanced. The balanced force won't allow anything to move. Question 2.
One side.
Alright?
That's my question.
Yeah.
If it's balanced, that means zero, right?
That's right. So, in question 2, we had a couple people who struggled with this. You have 200 on this side, and then you have 75 newtons here, and 60 newtons here. What do you do with those 2 arrows? Because we had several people out on Friday. You added and you got 135 newtons, right? All right. And over here you had 200. So a lot of people said 200 minus 135. And believe it or not, we got several people who said 70. All right. This is 65.
I did, because I didn't add that on the 5.
I know, but it happened lots. Okay. So use your calculator so you don't make that mistake on the test Friday. Because these are in for response on the test. So make sure you don't make that error. So 65 newtons. And once you do that, you have to give me an arrow. This was a 7-point question. Without the arrow, I took 4 of your points. Okay? I took 4.
I forgot.
You got to tell me the direction. Which direction is bigger, the right or the left? You had to show me the right arrow. Without that, you lost your points. All right? Shh. Is that balanced or unbalanced? It's unbalanced. Now, the second one, where you have the arrows going 400 newtons this way, and then you had 200 and 200, this is going to do what? Okay, so you get 400 newtons, and then what happens to this 400 and this 400? They cancel out. So you get 0 newtons. Now, Chris thought I said you didn't have to write the N. All right, you have to write the Newton on the answer. You don't have to write the what? You don't have to write the arrow because the arrows or the directions cancel out. You do have to write the Newton. Okay, so make sure you write the N. Put that down. No, I don't. These were high enough. I would not do corrections on this. All right. The things at the bottom, for the most part, everybody did great with. So I don't really have any issues at the bottom unless you have a specific question. Because very few people got anything at the bottom wrong. Does anybody have a question at the bottom they want to ask about? Not argue about, ask about.
Who said that? I didn't get
Yes, sir. G, when clothes rub together in the dryer, they flip end to end, and the clothes actually do rub together, so it's sliding friction.
Hey, look, I got you too, 'cause
It's not rolling.
I wasn't rolling. Oh, because the dryer's on in the second you think it's rolling.
This wall. I was about to put
There's no wheels or balls between the clothes, which is not why it's not rolling.
this
friction.
wall.
I mean, even though the driver stop and sit down in the chair, sit in the chair before I send you out for being a major distraction.
Oh, I play on you just finished.
Really?
To close, yeah.
You're asking me why you're a distraction because you don't know?
Hey, bro.
You can't figure it out.
I can't figure it out.
Just sit down.
Bro.
Between
Sit down.
the swinging of your drumstick and the dance, sit down.
You want to fight, bro?
Don't want you to swing the long.
I just need you to sit there. Thank you very much. Alright, but there's no wheels or balls between. Even though the dryer itself is circulating and it's spinning, that itself does not make it roll in friction. You would need something in between the clothes that would make it roll in friction.
I just like, you might have said the points off.
You been sliding from the dryer and I'm part of your roll? I'm sure I did.
I'm sure he erased it and wrote it.
It's more what I'm thinking.
I didn't get A.
Hey, Miss
A
Walker.
skydiver, anytime that you fall through the air, it's going to be fluid friction.
It's the air, man. What you sliding on? What you rolling on, man?
Yeah, it looks like
Stop now, you're moving.
Isn't that one that-
He's trying, you can't erase stupid.
That's not erasing.
She ain't gonna move. Open your parachute.
You don't need to open the first, you can just die.
He was right there the whole time we was on.
It's not the falling that kills you.
He
It's
was
not the
erasing
fall
that
that
shit
kills
like
you.
this.
It's the sudden stop at the end.
Yeah, but you just die.
It's not.
It doesn't matter.
That boy know how to cheat.
Alright, anybody else? Questions? Alright, let them back in so that we can move on.
I got it.
I was gonna say, you had one like that, but it was
Hey,
like
true.
a washing machine.
She hacking.
Yes, but the washing machine would have two right answers.
It'd be fluid.
Fluid and
I was finna slide.
sliding. Either one would be right for the washing machine. Because the washing machine has water in it. So you can say fluid or you can say sliding. So I would take either one there. Are they lost?
Yeah, they are.
Come on, Timothy.
Alright,
Come on, Carl.
find your notes. We gotta finish, wait, and then we're gonna do a lab that's gonna drive me crazy. Yeah, gotta pull the video up.
Please tell me not a lot of notes.
There's not a lot of notes and the video's 10 minutes or less.
That's not sure.
I'll appreciate it.
The notes aren't long.
Can I go get the water?
There you go. Pop.
Now I get it.
Oh, we didn't do number 7. I jumped over what I wanted. Eliminate number 7. We'll come back to number 7. I already scratched it. Let's see if I have my link. There it is.
No, it was bad.
She was bathtub picture, so she put water in there. I got the rest
You
of
probably did
Google.
I ain't calling, I told you, tell me what. I ain't calling. Oh, Great. He said, okay.
Get out of here. Yep.
Yes, we go.
Well, you can get it right.
He said.
You went.
Alright, I've got the video ready when it's time to get to it. So, if we move on, so that you're not talking red. Galileo is a guy y'all should have heard of before, probably in elementary school. He was an Italian. physicist. He also did some astronomy kind of stuff. I don't remember who involved.
I don't remember how.
He did work with the moon. Okay. He did lots of stuff.
Is this gonna be a long one?
Nope, it'll be about 4 slides. It's got another math formula. But the nice thing about this math formula is it's the same as the last math formula. Now, Chris. Now, Galileo's experiment is not all that complex because all he did is he essentially, let me change colors, is he dropped 2 cannonballs. Are y'all listening? It's very difficult to listen and focus if you're talking. All right, Cynthia, do you need to sit someplace else?
Yes, move right there.
All right. He dropped 2 cannonballs off the leaning. Exactly. The leaning tower of Pisa, which is in Italy. All right. Now, many of you have probably seen it, maybe in world history class, maybe in art class. It's a famous tower in Italy. It was built and it leans.
I want to go to Italy.
It would be a really cool place to go. What?
That kind of go together.
Okay.
Tower Pisa.
Pisa.
Oh.
Now, these 2 cannonballs that he dropped. All right. Then just say, excuse me.
That was not cute at all.
One cannonball had a mass that was 10 times larger than the other. So, just so we have some numbers to sort of keep in our mind. So, for example, the first cannonball, we're just going to say, is going to be 10 pounds, just to give you a reference, because kilograms wouldn't mean a whole lot to us, okay? We'll go with 10 pounds. And the second one, that won't be 10 times greater, would be 100 pounds. Okay, just so you have some numbers to keep in mind. All right, I don't know what the real numbers were that Galileo used. Okay, I'm sure I could look them up, but I did not look them up for the purposes of this discussion.
Euros.
All right, but
What that dedicated was from.
you're right. I did not use my time this morning to look up the weight of each individual cannonball.
I know that's right, girl.
So,
You ain't even seen that kid.
if you can envision scientists at the top of the Leaning Tower of Pisa, 2 old metal cannonballs like they used to use back in the 1800s, late 1700s, and he's going to drop these 2 cannonballs off the side of the Leaning Tower of Pisa. Now, you know they're going to be shaped the same. One is going to be 10 pounds and one's going to be 100 pounds. Now, the question is, what happens to the cannonballs?
They drop.
They drop. Do they land at the same time? Or do they land at different times? Okay, that's the assumption that most people would make. What, Drew?
Same time.
That's what happened. Okay? Now, most people assume that because they are different sizes, that they will land at different times. Each cannonball
How's that possible?
landed
What's heavier?
at the same
You stupid.
time.
Talk about it.
Okay.
Friction.
I'm going to, but I'm also going to show you a video to illustrate this.
What's that thing that's like, what's heavier, like a pound of bricks or a pound of feathers or something like that?
It's each of them are a pound, so it doesn't make any difference.
No.
Nice.
A pound of bricks and a
I
pound of feathers is a pound and a pound.
know.
Now, if you ask me which one has more volume,
No, I was.
the bricks are going to have less volume and take up less space. A pound of feathers is going to take up a whole lot of volume. Are you listening to
How
me
you do
now?
that?
Yeah.
Okay, a pound of brick is going to be very small because it's dense. The feathers is going to take up a whole lot of space because it's not very dense. A pound and a pound is the same mass, the same weight. Okay, but the difference will be in the amount of space it takes up. Okay? Now, does everyone have what they need?
Yeah.
Catch up with me and we'll talk about how this is possible.
Y'all both gonna hit the ground at the same time. Yes, y'all will.
Yes, you will.
It's fluid friction, my G.
I'm telling you.
Higher than the other one.
Doesn't matter.
It makes
Now, there is a way for one of you to land faster than the other. And we're going to talk about that. That's where I'm going with this discussion. All right. So, Galileo's conclusion. Okay. Galileo's conclusion. All right. Drew, hold that thought. Hold that. That's number 4 on the agenda, so hold that thought. Okay? No, we cannot drop food on the floor. We'll have major bugs.
No, it's in our mouth. Like somebody lays on the
You
ground.
tell you what, when you go to work later today or you go home later today, try that at the house or at Sonic, not here. There you go. And then tell your boss you're checking out Newton and Galileo's principles to see if they really work.
You gonna be like,
Say goodbye.
Galileo in
All right. So, Galileo says all objects fall at the same rate, regardless of size or mass. So, Galileo is saying, if he shoves me and Devin off the Leaning Tower of Pisa, we're going to fall at the same rate.
What if you
And I'm clearly bigger than Devin is. But we're going to fall at the same rate and land splat at the bottom at the same
What if
time.
you push one of y'all first?
Now, if he pushes us at different times, don't even try to check that phone. If he pushes us at different times, clearly we're not going to land at the same rate. That is assuming that we're pushed off the building at the same time. I'm not jumping off the desk. I'm holding my bones of fruit. Okay? No.
I'll jump off the desk, me and we're going. Let's go.
Just jump off the chair.
No. No. Now, y'all are going to get a chance to drop stuff. Now.
I got some.
Okay. Now, you want to come over this side?
You lied.
No, I didn't. Now,
You got
if we look at Lewis's experiment here, which again, we're going to do a number 4 in our lab. Which we have a piece of paper and a pencil like Lewis has.
That's not gonna fall at the same time.
They didn't fall at the same time. So why didn't Lewis's
This
paper?
paper is paper thin. It's
Okay, so there has to be something else going on. So,
Paper don't got no weight.
all objects fall at a rate of, write it down, 9.8 meters per second per second. So, if Galileo shoves me and Devin off the building, we're falling at that rate. Both cannonballs fell at 9.8 meters per second per second. If you skydive, you fall at 9.8 meters per second per second. When Drew dropped the water and the pencil, they fell at that rate. DeAndre's pencil is falling at that rate. Now, some things don't fall at that rate. The paper that Lewis dropped, it sort of floated down. It didn't fall at 9.8. Because what? So, there's something that's slowing it down. If we neglect air resistance is friction. Stop, we're not playing soccer with paper. Okay? Air resistance is friction. It slows us down. So, let's say that Galileo shoves Devin and I off the building, and we all have our arms and legs out and our shirt out, and we're trying to slow ourselves down. Are we going to fall at 9.8? No, we can try to slow ourselves down. But if we do like Drew said, if we do like this, we're going to plummet to the earth at 9.8, and our splat's going to be worse. So we can try to slow ourselves down, and we might fall at a slightly slower rate. But when he dropped those two cannonballs at 10 and 100 pounds, was there any difference in their aerodynamic design that could slow them down? No. So it didn't matter that their masses were different. They fell at the exact same rate and landed. So their mass had no impact. The only reason that Devin and I might fall at a different rate, even though I've got him by probably 120 to 150 pounds, is that I might be able to use my legs and arms and my shirt and my pants to create some air resistance. Slowing down. That's it. That's all I got. Otherwise, we're falling at the same rate. Okay? Now, I got him by a little bit. Some of y'all are going, ain't no way.
Yeah, about 10.
So,
legs. You watch the video so we can do our layout.
we got to learn one formula, but it won't take long. Oh, you dumb thing.
30 minutes. I sat down with
Hey, Jonathan, will you get the lights? Now, while this is playing, don't talk, so you can hear it. While it's loading, let me give you a little background. This is an old missile silo somewhere in Eastern Europe, if it will actually load, where they're going to do this test at. So it's a very large cavern. It's only a little over 4 minutes. Hopefully it's going to load up here. And they're going to test dropping a bowling ball and a feather. Okay? And most of you know a bowling ball and a feather are not the same size, right?
the feather's heavier.
All right? Feather's heavier. All right? They're going to drop the two, and they're going to demonstrate what will happen when the two are dropped. Now, when the two are dropped, which one should land first?
The
Bowling ball. All right? If you do it in a vacuum, you put that hat on again, this will be mine. Red's my color, no good on my head. Then don't wear it, or it's going to be mine.
Real right or something? Oh, missile.
You don't think? They play this ball. See that? See, and Marie was over here. Oh, thank you. You're welcome.
All right.
This is NASA's space power facility in Cleveland, Ohio, and it is the world's biggest vacuum chamber, used to test space in conditions conditions of outer
I
space.
can't listen to you.
And it does that by pumping out 30 tons of air in this chamber until there are about 2 grams left.
I'd love to go on the
And
past.
it's got an eccentric construction as part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel, so that this thing could take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one, and dropped them at the same time to see which fell fastest.
The feather one.
Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So in order to see the true nature of gravity, you have to remove the air.
It's not scary. Like, apocalypse, that's what you're gonna do.
It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber. We dropped 2 millitorr in the last 30 minutes. But once it's complete, there's a near perfect vacuum inside.
6148, 10% open. Station 1, go for drop. ECD 30-1, pressure set point at 240 psi. We are go for drop. 7, 8, 7, 5, 4, number down, 2, 1, release.
Why is it sad?
I don't know why they put sad music.
They don't cry. They must want you ready. Oh yeah, let's go. Look at it, look. Come on, that's just a long effect.
Exactly the same.
Alright, so the feather's slower? Same time. So even though you don't believe me,
But at first, it was the thing.
Isaac Newton said that the ball and the feather fall because there's a
you're
force
following at the
pulling
same
them
rate.
down. Gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this: the reason the bowling ball and feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if he couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the earth. So he concluded they weren't.
No, you were in there and they had sucked out all the air.
His thoughts of his life.
It'd be like being in outer space. I have no idea. We're not gonna find out.
That's that. Can we watch that? Can they?
No, that's not part of our lesson.
What about the eggs?
No, I don't care about the eggs. Go watch it yourself.
Okay, keep it.
All right, John, let's turn the lights on. All right, so to calculate weight. Now, the last formula for the test. as the one that's on the board. Does it look similar to something we've done this week?
Yes. No.
Yeah, yes. What does it look like?
F equals F like F
Yes. The two formulas are interchangeable. If I write F equals MA right above it, they're identical. The only difference is G is gravity. G stands for gravity, and A stands for acceleration. Now, they are one and the same. It does not matter which formula you pick. Devin, pick your head up. All the way up. I don't care. When you run out of hall passes, you just have to serve detention. 10 minutes and lunch. But it does not matter to me. Okay. So, now, if you look at your reference table, this formula is called force, and this formula is called weight. They are the same formula, but one is labeled weight on your formula sheet, one is labeled force. They make absolutely no difference which one you pick. Okay? So if you read a question that has weight in it, and you're like, oh my God, I don't know which one to pick, it doesn't make any difference. You can choose either one. Okay? Watch language. Okay? You have what you need?
No.
Okay. Tell me when you got it. Because we're going to use these formulas to do the lab. Because you got a calculating section and you've got a dropping section that will drive us all crazy and give us a headache by lunch.
Okay.
Let me cut the volume down on this. I can hear it bouncing off the board or off the wall.
That clean.
That's better.
That button me up.
All right. So, if I ask you to do this, okay, this is how the question is different. So write this down so you've got one that's different. All right, if the question says, what is the weight of a ball with a mass of 15 kilograms? How is this question different from the ones we worked yesterday?
It's asking for the same thing.
It is asking for the same thing, but it said what? What did the word use
Weight.
yesterday? This one says weight, and what did it say yesterday? It said force yesterday. Okay, the question yesterday said force, and this one says weight. Okay, so if you look at your yellow card that I gave you, when you look up the yellow card and you look up the formula that says weight, what does it say beside weight? F equals, there you go. So when it says weight, it says F equals mg. Okay, that's the only thing that's different.
What's that mass times?
Gravity. Okay, so when you look up weight, it says F equals mg. So which letter is weight? It's F. Okay, weight is F. Okay, this is weight. That's weight. So you're looking for the F. So what's the mass? 15 times what we learned G was yesterday. So you just put 9.8 in for G. So F equals 15 times 9.8 is 499.
Wait, never mind.
147.
147. Now, what unit did we put on an F yesterday? It was a Newton. It's still a Newton today. A weight and a force are Newtons. They're the same thing. So it doesn't matter if you call it a weight or if you call it a force, it's the same concept.
So for G, you'll never have nothing different.
It'll still be 9.8. Yeah. And if you forget it, if you look it up on your yellow card, down on that right-hand column, it says G equals 9.8. So if you forget it, you can look it up. Okay? Now, what if we wanted to go backwards? What if it said, what is the mass? Yeah. Because I gave you weight is this, what am I giving you? That's right. I gave you the F. So I'm giving you the 745. We're solving for mass. And what's the G? That's right. Is everybody okay with that? Sure thing? You sure?
76.
Is what?
76.02.
And what unit goes on a mass? Who?
KG.
KG.
Oh, my God.
You sure? Okay. Who wants to be my assistant?
Me.
Can I please this out?
Well, can I pick the partners then?
No.
She don't like that.
No, I'm going to speak everything. I'm going to let you speak everything. Except you. Whatever. How many people go ahead there?
I mean, it is for you.
21.
22.
22.
She was I don't know who you're just bro.
They call the plug called me.
Nah, you never did. Okay,
It's like somebody gonna have to talk like that.
Oh, yeah, what's that?
I gave my son, I already messed with him after he said.
We got this one already.
Are you there? Is there? You got one of these? I gotta get
Are you not handing out paper yet?
hurry up, Louis, dang.
Shut up, Rachel. Wait.
I did that one.
Oh, he got a break?
Does everybody have a lab sheet? Because I feel like I have too many in my hand. All right. Now, there are two parts to the lab. The first part is the math part. So, you're going to need a triple beam balance. In the cabinets, do not take the ones off the top row. Ones on the top row are usually the ones.
Yeah, 4 foot. That's really fun.
The ones on the top row are usually the ones that are broke. Otherwise, you don't get those. All right, and after the ones we finish with that, we'll put the scales back in the cabinets. Notice they're not backwards; they're facing out, so make sure you put yours up correctly. Now, you're going to need to change grams to kilograms. So let me show you something so that you can do that. So right under where it says kilograms, I want you to write this down so you know how to do it in a minute, and you're not all going as well. I don't know how to do that. All right, where it says kg in your chart. Right, divide 1,000. Okay? So, over here where you have your in grams.
Oh, so we put that where it say in kilograms?
Yep. So, let's just say in your first one that you have 145.7 grams. So, when you go to fill in kilograms, what are you going to do? You're going to divide it by 1,000. And then you're going to write in your answer
On the acceleration.
right there. Okay, for kilograms. Now you figure out acceleration and force. All right, now on the back side, I just asked her if I had one like 3 times.
I wouldn't pay attention. I wouldn't get
Really? You weren't paying attention? It's a shock. Now, on the back side, this is the part you need to pay attention to. Now, you're going to take the 4 objects that are on the back side and you're going to drop them. The uncrumpled and crumpled paper, just get somebody in your group to get a piece of notebook paper that you can crumple and one that you can uncrumple. Yes, it is. I'm so sorry. Now, one of you is going to need to take the stuff and drop them. And one of you is going to need to watch to see if it lands at the same time or different times. So in your back data table, the back side, see the little X's? Don't put anything in the box where the X's is. And the other one, write down, do they land at the same time? Do they land at different times? So for the example, wood block and styrofoam block, drop them. If they land at the same time, right, landed at the same time. If the styrofoam block landed first, right, styrofoam landed first. If the wood block landed first, right, now wood block landed first. Okay? And then ask you questions at the bottom. See what happens. Okay. All right, get started. It's due by the bell. And there's 20, you said 22 people here? So there's groups of 2. 11 groups of 2.
So we're just waiting for
Yeah.
You dropped 2.
Not 3 things.
Why you use 2 out of the 3?
You do each of them. Start from once, and then do the wood block and the paper.
We don't work right here. Who's your partner?
It's supposed to be 2 in the group.
It's supposed to be 2 in a group. 2 people per group. Find a group of 2. No groups of 3.
Which one you want? You want a black or brown with no race?
I think it's more than 22 people. I think it's like 23.
There's not 23.
It's on 22. Go get the ones from the top. Somebody got one from the top.
They want to work with me.
You don't have a partner. Guys, why are y'all working in strange places like on top of the computer cabinet? There are 6 lab counters with 2 sides. With the exception of Drew's table back there, or maybe the floating lab counter that Tim is on, the rest of you should be at a lab counter. And don't you put it back. But you are the world's worst. If you put your calculator up, moving my furniture back. You keep making me do that, you're not gonna have supplies.
Alright. Is that recording? Is that recording?
You just stay. It's the way it works. Y'all think about it. Try not to shove across the counter.
Y'all have to use that.
Okay, you do
I was never saying, bro.
Bro, you got everybody saying my
Hey,
Right, especially now on the bus. Girl, I know. Have a good. I'll bet way too much. Oh. He's wild.
I am not wrong.
Wait. What's my time? Down, I'm sorry. I'm gonna. Gravity. I'm
Wait, no, she say.
Abigail's not typing either.
So we do whatever.
Like this is.
Wait, oh, she said. So she said.
The room. Wait. That's how it If you have 0, 0, then you have
So,
okay.
if it's called, I'm waiting for Jones hair.
I love it.
Yes, I'm sure you showed me, I don't know. What are you talking about today?
Every night.
They said maybe it was a soulmate.
What are we doing that 2 days doing? What are you gonna do with all those objects? In part 2. We're gonna do what with it? Y'all gonna do what with it?
When I think about 30 something, he's like
The backside. When I say y'all we're gonna do those objects.
dude, he is a teacher.
Wait,
He not want to.
Where you go? Here, DeAndre. It's 9.8. No, that's for you to use.
So what's acceleration? What's acceleration? We're gonna do them after 2 days. Yes. Acceleration.
Which one of y'all crackheads got paid?
No, not mine. That's mine.
Oh. You're not even new. You're not even recycled. She left and came back.
Oh, God, my knee.
Where she wanna What's on the year old man like that? Boy, not like you said, he ball already. He did not get because he used to keep me out his
I'm hard to. What are we gonna do?
What?
So, what is the
Boy.
It was a talk about what acceleration is. And y'all don't know.
Yes, sir.
Now you start bringing up, help me regulate my
You already know, see,
What?
I got a headache, don't you? How long does it take?
Why did it fall? Why did it break? Memphis Bounce knows. What's acceleration? So what is it? I said she was here for 2 days. You were here for 2 days.
Well, somebody just wrote on one day. Well, I swear that's how you push.
Oh, no, I did it right. 13.5 times.
What's up? She's like, what? No, she didn't say that.
Do we know what that was a mask?
Well, why do you well, especially what you got to play out. You got like. What you say? What is nobody? They just fight when they hit there. And it was last year. I didn't go out. That's all. I'm not. Well, I don't know the answer. That's like 50,000. That's like I've heard.
What are you gonna do with all those dollars? What are they gonna do? So what's the salary? What did we just spend 2 days?
That's it. Who is me? Oh, the next day. Well, I like the conversation.
So do we just like same one?
Well,
Yes.
I need Nathan Suarez.
Okay.
It's not here.
Guys, when you're calculating, hey, listen, when y'all are calculating force, are you using the gram or the kilogram? Make sure you're using kilograms, not the gram.
That's it out.
Right, that's what I said.
No, you dropped the
No. Alright, so what is your acceleration? What do you do? Okay, so what do you want to say the acceleration is?
Let's trade up with
Right, Chachi? What?
You gotta teach them all over again. Teach them all over again. Everything, bro, guys. It's so. Bro, I said you can follow these two together. Course of it. I didn't make.
It's fine.
Why you got the wood block next up?
I just did. Don't put anything in the extra jar.
Yeah, we not looking this. What you ready? Bad last. What shit we going around? We doing it by cameras. They want AO. Look, and look.
Yeah.
When we get to the back.
Yeah. Just drop that stuff and record.
Like, what we record?
Which one landed first? Did they land at the same time? Like drop the wood block and the styrofoam. Bring your shot here.
I see what you're saying, but you marked out the wood block.
Right next to this. Like
First of all, let me ask you.
You're not gonna have to wait.
Sit down.
No, the first
It's right there.
Is one,
you gotta do that with the criminal record.
wait. Crumble paper, uncrumble paper.
Wait, you look at no time.
I did.
Yeah, you is a lot of them.
Do the uncrumbled paper.
He said, it's the worst of all now.
Always gonna be top. Say what now? Yeah, acceleration's not what it is.
Like I said first, don't you want
We called you.
We see it up there.
I will.
you know, trying to stop the celebration?
I did that. It was a tough struggle.
When you finish, bring me your lab sheets. You can get your homework. Yes, you have homework. Math homework.
She did it. She did her walk. Look, let's walk.
That's okay. Bring it here. Let me go get the tape out back.
That's what ours got taped though.
They all break eventually. I gotta go through. Hold up. Your grandma was way off.
No, I didn't. I didn't though. Oh. Oh, nah, I know.
Done? That's what I'm asking you. You can answer it 2 ways, as long as you're explaining it correctly. There you go.
What? That was just me.
Yeah, you could.
Y'all are down to about 8 minutes. The ceiling tile. Devin, y'all done? Y'all.
You ain't gonna pick them up, both of them at the same time.
I'm doing my work. I ain't even gonna feel that.
Remember, when you're done, put your scales in the cabinets.
Oh, my life.